Guess who's back?
I'm back.
As you know, a couple months back, I got my OEM++ engine put into here, ready to go. Isaiah was not here, and I started working on the 4-rotor, the 3-rotor, and you guys see all the craziness that we've gotten there. And that was all on my own. You know, when Isaiah's back, we're gonna be making some serious jams, and that's where this comes in. This is the G35 1050, and this will be powering this car hard. We also have his little brother, the G35 900, but that's gonna go in the Indy car. This could probably blow the Cosworth with how impressively efficient this is compared to 97 technology. But we are going to use this. A 1050 should make approximately 71% of that number in rotary power, so you're talking maybe 700 horsepower, but the nastiest 700 horsepower rotary imaginable to mankind. It's a one giant leap for mankind in terms of turbo technology. The GTX 3584 RS was a wonderful turbo, but I think I had it too low and oil problems became an issue, and as you saw, that's why it caught on fire in the middle of the desert in Vegas. That said, we're gonna get this thing ready to go to Vegas and stir up some shit out there. What's the plan? Well, my goal is to make this car as user-friendly as possible. Power steering, you got nice clutch control now, beautiful control with the power because we have the new turbo. This thing is gonna be an OEM++ Corvette. It already makes way more horsepower and torque than the LS ever did. We're gonna drive it to SEMA, do some shenanigans at SEMA, and then drive it back to the shop, all while making 700 horsepower. Something we're gonna do a little differently on this car is power steering. The different thing about it, this is electric power steering. If you guys are old school RX-7 guys, you remember there's a lot of threads on using the MR2, the Toyota MR2 pump. That is not the case for this. We're using something that's Ford Motor Company, FOMOCO, but it's also Volvo, because Ford used to own Volvo. So this is an old Volvo pump. Power it up, power and ground. Obviously it's gonna suck down the juice because this is a heavy duty, high pressure situation, and then probably some sort of pulsing or controls over that. Little tanks on top of there, and we've got feed and return. Nice and vertical, a little weird mounting tabs, but I'm hoping that this is compact enough to fit somewhere in here and play nice. And so we'll have Ford inside of a Chevy with also Mazda and a variety of other company parts in here. If you guys have ever heard the rotary vat idling or just starting up, you always hear it squeal, and that's actually this guy right here, the stock alternator. It has a sense feedback, right? But it doesn't tell itself to start working until about 1,000, maybe 1,500 RPM, where the car can idle really low. So you hear that squeal as this thing's clutch and whatnot internals are making tons of noise. Thankfully, we're replacing it with one of the DC power units. And what Isaiah is doing right now is welding it, the little nut on the back of it. We're making it solid for this car, so we have solid power for all the new things that we want to power.
What's on there?
You seeing the shapes in your head?
Yeah, trigonometry and stuff like that, you know? C minus plus B minus equals A minus, or vice versa, something like that. Instead of just figuring, okay, the header, turbo, you need to figure everything else that goes around it, water lines, intercooler piping, how you want the intercooler piping to look. Last time we had the intercooler piping symmetrical, so they come in at an angle and they come back out at an angle. But the way this is set up, I'm not gonna do it like that. I think since this is like a 90, I like the way the Garrett would be in line with the upper intake manifold, so that would look pleasing. And then if I have the intercooler pipe come this way and come this way, I could have this one run parallel with this line and then break off even from there.
The presentation's beautiful.
Did you hear what I said?
No, I don't listen.
So I want it to be straight, so that way when you look at it like this or even take pictures, Garrett's obviously really easily readable.
Yeah.
But then also in line with the upper intake manifold, so it looks nice.
Yeah, I do like that.
But with the way this comes, you know how we had it symmetrical last time?
Yeah.
So this way it comes like this. I'm gonna have this one come parallel with this piece of straight and then break off. So that way it gives us a nice area over here to put a scoop or something for intake or whatever. The only reason why I'm thinking about the angle is the downpipe. If I put it straight, the downpipe looks weird. If I bring it over here, it's too hot over here.
Yeah.
So I think if I angle it a little bit, I could get decent with the downpipe. This is my little turbo holder thing, because to try to fabricate a header and hold a turbo at the same time, I'm one man. I'm not really that strong, even though this is a small turbo. I normally have this one, but there's no way to put it underneath. So this would hold the turbo up here, And then this one's a small guy, so the little oil drain is what I hold it by since it's 2 bolts. So I had to make another one with another all thread because it got lost somewhere around here. I think that's gonna be where we put it. Rob has these on his gloves, and it makes me want to use them so bad. Rob, not Isaiah. Same thing. He decided to. How am I use this? The thing I hate about myself is if you tell me no, I want to do it even more. Edit it to where I'm turning white right here.
This is not for the video. This wasn't staged. I heard I'm turning white. I'm like, I know what he's doing. I know exactly what he's doing.
You didn't show him the thing, huh?
Oh yeah. To take off your watch real quick, I want to show you this one.
Yeah.
No.
No, dude.
I'll show it earlier. It's a way to like relieve your wrist. It's actually pretty badass. So this guy, just put your something over here. So I'm gonna have to hold it like this, and you have to like rotate in like a weird way. So if you like go like that, let's see. No, yeah, like that. You feel better, right?
I feel like you feel better.
Collectors all made, so I'm welding the inside. I always weld the inside of all this stuff first. So if you weld the outside and then you try to go inside and weld the inside, your outside weld will be all oxidized and ugly. Nobody wants that. So you always weld your inside, then you clean it up again, and then you weld your outside. That way it looks brand new and you have something like that. Well, while Rob gets his daily shower in.
That's pretty wet.
Yeah, this came out good. We'll lay right on the bike. It's hot as hell right now, but the collector is definitely gonna collect. We have our first runner here and a nice curvy, like some people I know. The hardest part is getting the first runner done. You have to allow yourself to get room to kind of equalize it. If you have to make up room, vice versa, if you have a short path. So I made it come out here, the short one come out here so we can take the longest length, and I have more room over here to make up length from however long this is. I'm gonna measure these two, then I have to match this runner to this one. But everything sits in there pretty good. There's room to get the wastegate to come under here. Everything's looking pretty trick at the moment. Metal. That's metal. Some math over here, and both of them are 14.5 inches down to the 16th of an inch. I'm gonna weld this guy up. Obviously, it needs some support.
I love it because you got the same.
Yeah, it's going to be the same exact thing how the 3-rotor wastegate was. I mean, wastegate's too good on the 3-rotor now, so somebody's going to go like this with different whatever. But it's going to come out, and wastegate's going to go wastegate, and it's going to come back this way, and then downpipe's going to come this way, then turbogen's going to come that way, and power is going to come in here, and it's going to go out through here. Science.
I love it. So we're going to do the clear chrome ceramic coating on this?
Weird enough, we actually have some time before SEMA. It's not like I'm right here and I've been working for 96 hours. We have time, and now that I'm here and I'm doing some hot parts, I'm not gonna let my boy do Chevy stuff anymore. He likes LS so bad, he gotta go get the Chevy chrome on the 4-rotor stuff. I look over there in the corner, I can't even stand the shimmer off of it.
I disrespected him so hard.
Ceramic coating only takes like a day or 3. We're gonna get copper on the inside, gold on the outside because it's fucking sick as fuck, and delete that because it's not brand safe, I'm sorry. The only thing I hate about having talented friends is that they give you a nice flange one time, right?
It's like, who's your deal?
And then you got to deal with other flanges and gaps and stuff like that.
Some scientist was like, I got here because I stood on the shoulders of giants, and that's exactly what this racing beat flange is to me, is the shoulder, the thing I got to stand on top of to make a subjectively better header.
Better.
Yeah, that rhymed.
Wow.
Yeah.
Bars,
Yeah.
okay. got good penetration on this guy. The welds look good. Now we're on to the other runner. Perfect timing. The guys over at TurboSmart just dropped us off our new wastegate and our new blow-off valve for this thing. And just like the 3-rotor, since it works so well, I'm going to put the wastegate exact same spot, and we're going to have complete control over boost, which we will need to kill all these LSs. The header is now welded. I just needed these 2 outside welds. I was waiting for Rob to kind of machine me something real quick so I could have a heat sink, but I'm just going to weld it, and he could complain about flattening it later because that's what he likes to do, you know? I asked him. He didn't do it, so he's gonna have to put it in the machine and flatten it again. I wonder what color he even got. Black, yeah, he would get black. Ooh, looking for the instructions there online, but you know, I know how to blow off valves. But yeah, there we go. Comes with a nice flange here. Boom, easy to weld. I love that. I love when they come with flanges like that. But we don't need as much control as the 3-rotor, so this guy is gonna be 50 mil. Another sticker. I'll probably give that one to Rob if he asks. Nice. Oh, look at that. Oof. Sheesh. Look how small that thing is. The top is very compact compared to the bigger one. Man, different springs that come with it to control different PSIs. I know that there's a lot more room. I don't know why, but I guess I'm accustomed since the last thing I did was the E-gate. I was like expecting huge and I was accounting for room, but now I don't have to. It's just, just gonna go just like that. This cap's gonna go back here. I'm gonna call it a nice day.
Supposed to give you a 50? I grabbed a 45, Rob.
Oh, it's still a baby.
Yeah,
That would work.
The 50 is only slightly taller, so.
Yeah, that is small, like in a good way.
Yeah, I grabbed you a 45. I'll swap it out for you.
Oh wait, your standard gate can also have temp water?
Yeah, it's not needed though.
Yeah.
In a lot of scenarios.
As this channel bears my name, I get to introduce all the cool stuff without actually doing any of the work. And with that, Isaiah's beautiful 2-rotor manifold.
this is her. She's stainless metal, handcrafted by these 2 hands and the 3rd leg. Can you turn around so the people can see you? Sorry, she's just really shy sometimes. This is her first day out here. 14.5 inches from head to toe. She's dressed with beautiful colors, wearing a nice stainless finish.
It really promotes wastegate flow. This is super exciting. I want to show you guys a quick difference between the previous setup and the new one and show you all the upgrades that we've done. First of all, the old setup starts with a phenomenal base, and in fact, I wish I could reuse it. It's Turbolone's base 347 stainless steel, really short header. It means business, but that's really meant more for the Borg Warner EFR series, not so much for a Garrett. We had to do a custom exhaust housing to make that work, and with that, we had to put a wastegate on that. And I do think that affected spool considerably, especially because it was divided. It is beneficial to be divided, and then it's undivided halfway through the housing. That has to affect spool, and we saw it when we compared it to other 3584 RS turbos. That said, the turbo is sadly sitting too low. What caught fire initially years ago was the fact that the drain was very low to the car, and the front cover input for the drain was very high. So it's a very horizontal draining situation with the way rubber hoses work. They have to radius, they have to bend, and so it looped down and created a little pocket of oil that of course would cause the turbo to back up, and then crankcase oil would come out of the sealed area here, go into the exhaust, and worse yet, go into the intake. That problem aside, this was a great simple setup, but it really wasn't ideal. It wasn't perfect for what we're doing here. That's where we made a lot of major adjustments to this First of all, going with the G Series 1050 turbo, it is a V-band setup, so we don't get the benefit of being full divided. There's no way we can harness that with this series of turbo, but using the same technology that we did for our E-gate, we have this beautiful ability to control all of our boost through a 50mm wastegate, and then of course go up to the turbo and make all that power. This will have full control over boost 100% of the time, beautifully, allowing all of that to get out. We could run it however we want, but I really foresee this being a faster spool and yet way more power because of this compressor.
So he's putting it in?
I get to do the fun part. Actually, making this is honestly, these are some of the funnest things to watch made. But
Yeah, to watch.
the Corvette really does have a nice amount of room though for everything compared to an FD. I feel like this chassis is actually easier to put a small engine like this in it. So we're definitely using all the space given here for these longer runners. That's beautiful. And like Isaiah said, is that this we will actually powder coat, more specifically ceramic coat the inside and the outside also to prevent heat from getting out. The more heat that you can get to the turbo, especially with longer runners, the more power the turbo can make. But it isn't just flow, it's about energy. And energy is both heat and pressure. When you measure both of those together, you get the total amount of energy approximately going into the turbine wheel.
This is how a bandsaw is supposed to cut, like little baby thing, cuts just straight, you know, no problems. Didn't die, didn't cut myself. Just fucking bandsaw right there. I got a smaller piece over there that I was saving. Here, I'll bring it. Look at that. That's what I'm talking about.
This is super exciting for me. This is actually the second moment, it was in the last 15 seconds before Joel started filming, that I got to see this beautiful downpipe for this new setup.
It's down and it's a pipe.
Yeah, and there's plenty of room to get the wastegate to recirculate as well.
So it's recirculating right there, nice V-band, nice angle right into here, doesn't disrupt the flow of the downpipe. Everything is looking pretty good. We have downpipe, wastegate recirc right into here. Everything is all good, dandy, welded to go, fully penetrated, easy, beautiful, pretty, just like me.
Cover girl.
So this is me getting to be the videographer right now. And look at this whole setup before we go and powder coat the inside and the outside. Ceramic coat, even better than powder coating. All ceramic coat is powder coat, but not all powder coat is ceramic coating. And look at that, look at those beautiful welds, just gonna be hidden by titanium color ceramic coating. We're even gonna do at least the lower intake manifold, maybe even the upper too, because I polished those with a wheel, but they've always looked off. And those are even some of my early welds, first welds into cast, right down there. Even though this flange right here looks completely flat, as many of you guys know from the channel experience, that is more than meets the eye. So it actually looks really close to flat, but that little bit can make a huge difference on sealing, especially when you have exhaust gas, high temperatures, high heat, just violent situation all the way around. So what we're gonna do is hopefully make sure that this is enough to brace this. I'm a little scared because it's hanging off of this side, but that's holding in pretty solid. We're gonna face that off with this tool right there, the facing machine. That can get pretty violent, but I'm gonna go really soft, really slow, and we'll do it in a couple passes and see if you can see where it starts to bubble up. I'm actually running the machine right now at 1,000 RPM. It's sitting above the surface right there, about 15 thousandths of an inch, but look at right in the center of the screen. Look at that area right next to the exhaust port, or even right there in the center of the screen next to that other exhaust port. You can see those shiny spots? That is about 15 thousandths above the very edges of this thing. So my goal is not to take this whole face down. What I want to do is just take the center of the face down until it matches the corners. So you'll kind of see like a circle forming around each of the exhaust runners. This is really satisfying to watch. And just a temporary look. There's a little chatter on my end, but that can easily be buffed out. And this is the most vibrating part, but look at that. It's taking down 5 thousandths in the middle. We'll just go a little bit more until this circle grows to the outer edges. This one's not bad though. It's 15 thousandths from here to that spot that was right there.
It would be closer if I had a heat sink.
So now that Isaiah's gone, look at how bad his welding. Oh, dude, oh, I didn't know you were right behind me. This is another 5 thousandths off. And it's really getting close to being finished. So you can see this moment right here is going to show us right there. That was the worst part of the whole thing, but since we started really shallow, it's kind of sounding a little more consistent. Just the past two, and Joel brought up a good question, is what about the area under the arms? And that's exactly what we're machining it down to. I learned a couple of things, but I'm very happy with how this turned out. It's way flatter than Isaiah has ever gotten close to doing. And
What he doesn't want to tell you guys is that we have two different definitions of flat.
Flatness I go for is on the molecular atomic level, and I am unable to achieve that myself. The problem is when the tool hits an area like this, it's always kind of in a sweeping pattern. Whenever you are running this machine, even though it is completely flat and square right there, as soon as it engages material, it's always going to sweep or adjust to that on the thousandths of an inch. Very, very minute amount, but it makes a difference, and you can see that right here and here and so on. I tried preventing that sort of vibration, but this is only like a thousandth, if that, of deflection. So we'll just take this down a little bit more outside of here, but that 15 thousandths of an inch is gone. It looks crazier than it is, but you can certainly see how much it still has left over here. And if we were trying to seal all the way to the end, we would have to take this whole face down even more. Thankfully that is not the case, but you can see just how much that had warped and how much we were now flat to that warpage. You can borrow from my engine building experience and make this just a little bit more smooth. I'll show you what I'm going to do. In this case, getting stone means something a lot more productive. And what we're going to do is take a 400 grit sandpaper and use it to a stone that is actually pretty solid. In this case, we'll use the smoother side. It's got that shit in there, but it is actually very, very smooth. Get it all lined up like that. We'll allow this to tell us one more level of how smooth this is or is not. Some people in this building think that belt sanders create smoothness. I'll tell you right now that is not correct. Due to extenuating circumstances, we weren't able to get that ceramic coated in time, and we will right after events, which means it'll never happen. But I wasn't able to get that flat in time for Isaiah to then take it and get it to the company to do. It's a hard lesson to be able to admit you're wrong, but Isaiah will get better at it sooner or later.
It takes them about a week or so, and we want to kind of get the car done by Friday. We're weird because we're in a low stress environment today, this week for the SEMA. So let's just, vibing out, and it's not like last time where got to work 96 hours straight. So we're just cruising. Everything's getting done properly in a timely manner. We'll just do ceramic coat another day and make a better video for you guys.
Oh yeah, that's flat. I feel that.
How's it going?
All these V-bands are fucking me right now.
Aw, that's not the only thing he wants to. I'm gonna try and be an adult, and while he's here, I'm gonna show you guys a really cool little thing that we are doing with this car. This is the stock water temp sensor as well as the stock oil temp sensor. We also have a pressure sensor. So there's 3 sensors for the stock car that are shown on the analog gauges on the dash. I have retained the wiring for all of that. That's why that huge loop of wires over there is still there. It's all the stock stuff. And we are going to add bungs for these into our setup. So that way when you turn on the Corvette, like Isaiah was just asking for clarification, he's going to be welding them on, but they don't exist. So we are going to have to make them. The cool part is that it's going to have oil temp, oil pressure, and coolant temp. So we don't have to have a dash, we don't have to have anything else. We can just use the stock Corvette for those three things. I'm also going to try and get the RPM to work as well. These sensors, unfortunately, on an American car, use metric threads. This isn't an NPT. It's weird that all of our Mazda stuff is all NPT, and this is all metric. So this metric thread has given us a little bit of a challenge. So check this out. So from the last shot, there was about maybe 10-second delay, and thankfully during that time, I got this built. This is probably one of my finest creations. You could do this too with a couple tools found around home, some in the kitchen, and a $300,000 CNC machine. Plus very expensive tools. With all of that, anybody can do this. I've created a nice little threaded hole. This I don't have the tap for, so we are actually using a special tool that just has a little triangle scooping and cutting each thread out. The problem I have right now actually is that the threads are so perfect that it makes it very hard to thread them in. There's no room for error. This one is meant for the pressure sensor. It's a little squatty 16mm wide thing. And we're gonna turn this into a little cylinder that Isaiah can weld to somewhere on the oil system. This will be an oil pressure sensor. We're gonna make this into a nice little cylinder. Look at that beautiful little wisp. Man, that is smooth. So like I was telling Isaiah earlier, it turns into a little hat or a house, and we're just gonna lop off where I stopped the finishing. You know, this is all the real pretty part. This very bottom part will be where he can weld and do wild things to. So I'm gonna use this. It's a much smaller bolt. Sadly, I don't have the full-size bolt, but it is the correct thread, so that way I can hold it a little bit better than just out here and push it through the bandsaw. So I'm gonna be very careful with this, of course, because what is the bandsaw gonna want you to do? It's gonna pull it down like this. I don't know how to use Isaiah's bandsaw. If you press this and this. That actually turned out really good. That is a really smooth running bandsaw. There we go. I even protected the smooth, beautiful surface of this thing. I did not get it flat. I messed that up. That can be easily fixed, but there we go. Meant for these little temp sensors that are M12s. I gotta stop making the threads so damn tight. I'm gonna go ahead and do the same thing, cut this off of this block. Well, this is a C5 Corvette pressure sensor, and they even call it a switch, so I'm not sure how much pressure it's sensing. It is a 3-wire, so it should be able to send out voltage based on pressure. I just don't know how accurate it is. But then this would then screw into here, and the rest is history. That is a lot.
I put like 10 bungs on this thing. This has probably been the most modified radiator ever. This sensor is actually for the Corvette stock dash, so he'll be able to see whatever this is approximate, because Corvette doesn't really care about how hot it is. It's a LS, it just keeps on running apparently. This is turbo coolant. This is heater core coolant. This is sensor for the water pump. This is feed, which used to be right here, but we had a problem with the hood thing, so we're gonna move it to right here. Shock. Kept on hitting it.
Out, coolant in, and then we also have oil coolers, which actually did work for the first run.
And all, behind all this is just one fan doing its best. This isn't even. It's not even a Spalt fan.
It is a Spalt fan. It's not there.
Oh, it's dirty. My bad.
Yeah. We're about to do something kind of cool out of desperation. We need to adapt from this guy to this guy. I love having consistent intercooler pipes. I love having the same on both sides. These are both 3-inch diameter, and this turbo is so efficient, it is much smaller. What we're gonna do is put this in the CNC machine, cut this down, which we could just cut it off on the bandsaw, but I'm gonna cut it down, machine it centered to this hole, clean it up, make a nice gradient, and make a nice cone shape from there to there. Hopefully make it all press fit, Isaiah can work his magic, make it look beautiful, but we'll have something that adapts that and looks pretty good to the eye. About to do something pretty crazy. I'm gonna try to take it down a third and then another third, leaving me about a quarter of an inch of this left for me to do my magic. But I'm gonna blaze through this, hopefully, because it's off-centered, you know, it's not being pushed down from the center. Hopefully it doesn't go over that way. We're gonna turn the coolant off for this. With this now, I'm going to machine an inner lip so that way the piece I'm about to make can fit and push lock into there, and then that makes welding a lot easier, but it also makes fitment and angle 10 times easier. So the cool part about this now is we know exactly these dimensions, and so when I make my piece, it'll be the exact opposite, and it'll push fit right in. You can hear in the background that we've begun cutting the piece. It is a wild looking cone-shaped thing. That is scary to cut. So check it out as it cuts it around there. We're gonna do a rough spiral around the outside, flip it upside down, and then turn it into like a cup, and hopefully not make it vibrate to pieces. What it's doing right now is it's taking a major part down and then cleaning that section up. So you can see kind of this nice little cone shape forming to the outside of the transition. This is a roughing pass. Don't have your finger go this way, you'll get yourself cut. You can see what's going on there. You can also see how it's got those like sections, because it does it in those straight lines. So what we're gonna now do is get my curved one, which is right here, have that spiral all the way down this outer edge and smooth it out as much as possible. So here comes the finishing round, which should just do this beautiful spiral all the way down and take forever. I might have to speed this process up, but we're switching tools right now. Turning out way more beautiful than it should. It's technically going to be thick walled, so it's not like I could just buy a normal tube and do this, but it's making all this effort worth it. We're now going to have to cut this off right about here, and then make another mount for this, kind of like this one I just made down here. For this lid, or this cup now, flip the cup upside down and hopefully carve out the inside. I made this thick wall, even though it does actually go from the proper 2.5 to 3 inch outside, it does this real beautiful transition all the way from the turbo to the flange. So it should be fine. I hope it doesn't vibrate itself to death, but first we gotta cut it off from this block. So I'm gonna have to cut like right there, and Isaiah swears his bandsaw can do it, but anybody that works with material like this knows that a bandsaw with 20 teeth per inch is gonna have a hard time when a bandsaw with a couple teeth per inch will cut through this actually much easier. This is gonna take a minute. As you can see here, what we're about to do is execute one of the most dangerous things I've ever done on this channel, and that's why I feel like I'm gonna be more risky when I wear this stuff. We are actually about to do something kind of crazy, and there's the beautiful little finish from me doing all that bandsaw work, but we are gonna try and make a little cup, clean up this outside edge, because as soon as this gets thin wall, I think it'll vibrate a lot. So we'll do the outside edge, top, and then just start digging in. That's why I sank this thing into this piece a little bit further. I might have marked up a little bit of the side, but that's okay. I'm just gonna hog out the middle, and then we'll take a look at it. It'll be rough on the inside, then we'll come back with, you know, smooth tool, hopefully, to make the final pass. The thing is exactly 3 inches, so it shouldn't make much noise. Beginning is the scary part. That's insane. Whoa. That was sick. I think I can run a finishing pass on the inside of that.
I think it's a beautiful cup as it is.
I know it.
What are you gonna drink out of it?
The blood of my enemies? The blood of people who LS swapped their rotaries? That turned out amazing. Only this little lip here, but that's because I couldn't reach the tool down far enough. That's the only thing, but your weld that area, so it's gonna melt it anyway.
Melt the thing right up.
Yeah, so the bottom will have to get cut off as planned. I'll try running a finishing pass on the inside just to clean all this shit up. Wow, that turned out amazing. I didn't even really mark up the outside either, even though that's the area that's going to get welded. My bottom is just a little extra piece that I can guarantee hold on to here, so we'll just cut this back a little bit. But right now we've got a pretty sick cup.
Coolant in there.
That was fine. It was the coolant.
Oh, my bad.
We had to test it. It held water. That
is a good cup.
I can make my own silver. Holy shit! I don't have to do YouTube or car stuff anymore.
Yeah, there you go.
No more stealing Chipotle forks, dude.
Oh, you have to press it, huh?
Yeah.
Yeah, go ahead, press it.
Well, that's as far as I can press it. That still has to be taken down on the inside. Because it's going to push in a little bit more, but look at that.
I want to push it all the way in.
Don't do it. Don't you do it.
Show it to the people.
Look at that. The boost is going to come into here, right? And then, so this is how you make good horsepower. You back it up. We learned this on the 4-rotor. You back it up.
Yeah, you back it up. It's
and
really cold.
It will get there somehow. It will make a hole.
Isaiah does not deserve how this is going. So this is the flange that it's going to be welded to. Like,
Wow.
you know, weld onto that. Look at that.
Wow, it fits in there perfect. And it's going to be like that. Get reach. This thing is so small.
Just going to sand it down until it starts breaking through. My cup is sadly no more. I actually took the whole inside out of it just by cutting off the extra wafer that I had planned to keep it rigid while it was being held in the machine. I actually ended up putting it back in the machine upside down with my first set of clamps and taking it off with the face mill, and it held it in there quite nicely. So we have that nice center locating ring. We have a beautiful gradient on the inside, a really pretty gradient on the outside. Let's see how it all bolts up now while Isaiah's in the bathroom. That was perfect. That's press fit right there. You can't feel it through the camera, but very, very pleased with that. With this on top like that. Smooth transition from what existed to what we need. Joel is mortified that I'm actually finally wearing shorts for once, but I was working out before they all showed up. What? Like this is me not flexing.
That's a lie.
This is me not flexing right now. Isaiah had a chance to weld up my trumpet, my ass trumpet. Look at that transition. That was exactly what I dreamed of. It turned out beautiful.
There's only one problem that I had. And you know when you want to weld something really nice and you're like, yeah, this is all prepped and nice and machined, and then somebody didn't clean off the coolant, and it's like in there and it's pressed, and you're like already too late and you realize that, it's just like, oh. It's still welded good, but just...
Yeah, that's the problem with press fitting it, is that I wasn't paying attention and got all excited as you saw, and I slammed it down and locked in some oil inside of that.
It's okay. It's okay. It's all good. It's all good.
We just have random ass flies everywhere. We're gonna go ahead and get all of the wastegate lines, all the press fit lines, the back pressure sensor lines, all that stuff, make that look real pretty. We just machined the back pressure filter, so that way it all mounts beautifully and we can sense everything and tune it on the drive up to Vegas.